Now let's perform some transformations. You know that the base graph here is a square root graph, and this plus 2 tells you to take your base graph and move it up 2. Now if we just look at y equals root x, it goes through 0, 0, 1, 1, and 2, 4, or 4, 2. Those are numbers that should be memorized, and you have this basic graph for y equals root x. Now we are moving this graph 2 units upward, so here we go. Everything gets moved 2 units upward, and there you have your graph. Notice we don't need an XY chart when we understand these transformations. In this next problem, we begin with the reciprocal graph. It goes through 1, 1, a half 2, and 2, 1. So there's the curve in the first quadrant. And we have a matching curve over here in the third quadrant. There's your basic graph, y equals 1 over x, before it is transformed. Now, the minus 2 that you see over here basically stands for down 2. So each point that we have here is going to be down 2 units. And so here we go. Bam. And then these points will each be down 2 with respect to their counterparts up above. And we can draw this in. Notice how the graph still does not touch the y-axis, but instead of, as in red, we never touch the x-axis, now we're not going to be touching the line y equals 2 as we have going across there that I've just dotted in. Now we have a cube root graph. The cube root graph goes through the origin and these other 2 points, as I've just sketched in there very quickly. Now that minus 2, that's right there with the x as if it were in parentheses, so that's going to refer to left or right. Minus usually goes to the left, but we're doing the opposite here, and this is going to refer to right 2. So each point here is going to move 2 to the right. Let me get those points drawn a little more accurately. And there we have our curve drawn in after that transformation. Now we have a couple of transformations. This minus 2 inside the absolute values refers to right 2, and that plus 4 afterwards refers to up 4 units. Our basic absolute value graph has its vertex at the origin, and we are going to be moving each of those points over 2 to the right and up 4, so that will become the vertex. And then we have that same absolute value graph, which I've drawn in there now. Okay, this is a little bit different of a problem. They have given us a graph, and we want to graph 1/2 of it. Each y value gets cut in half. So let's start here at the left at -3, 0. Notice its height is 0, and half of 0 is still at 0. The same thing goes at the right. Half of 0 is 0, so we're going to go through 3, 0. Now, at x equals 0, we have a height of -2. Half of that is -1. So it's only going to dip down a little ways, and so let's graph each of those points there. And we're going to have what you might call a smushed graph when you compare those two side by side. In this next problem, the negative is inside the parentheses with the x, and this gives us a reflection across the y-axis. Rather than graphing it at the right, I think we'll have a more dramatic view here if I graph it to the left instead, putting the vertex down there, and basically forming a W, where here's the new graph, and the old graph was on the right.